Obrigada. I'm going to talk today about accessibility because that's what I do. And I'm going to talk about drinking tea because I'm British and that's what I do. I'm going to talk about CSS accessibility because I know this conference has a big focus on design. And although it's easy to think that CSS is a purely visual medium, there are a lot of ways in which it has implications for accessibility. For those of you who don't know me, I am blind and I use a screen reader, a piece of software that translates what most people see on screen into synthetic speech. So I listen to content instead of look at it. And that's going to be a big part of the way I look at accessibility over the next few minutes. Some of you who are older than others, and I count myself amongst these, may remember a film from 1996 called Space Jam. It starred some basketball players and some cartoon characters, and they saved the universe. The reason I mention this is because there is a Space Jam website. It was developed in 1996, and it has some very pretty stars in a nice circular pattern. And believe it or not, that website is still up. You can go and visit it today, 20 years later. So it's a museum piece as much as anything. But the reason I mention it today is to explain how design and code used to look 20 years ago. Basically, we didn't have CSS back in 1996. So everything in terms of design was part of the HTML. So if you look at the Space Jam website, you'll see that there is a body tag, and it has some curious attributes to define visited link colors, active link colors, background, text color, and a number of other different bits and pieces. And this was all in the HTML. So can you imagine what you had to do every time you wanted to change those designs across a whole website? That was changing this information on every single page. There were lots of information about formatting in the HTML. We used elements like center and no break to stop things wrapping across different lines. And again, this is all hard-coded into the HTML. We did things to control layout. We used tables instead of for showing tabular data. We used them to control layout. This is how that circular pattern of stars was put together. We gave things fixed width. Now this has a width of 500 pixels, which today would just be regarded as so old-fashioned. It wouldn't work on a desktop, it wouldn't work on mobile, it would be completely restricted and not convenient to look at anywhere. We also used other attributes like the align attributes on table cells to control the position of content within its parent container, like the table cell. And again, this is all hard-coded. We did the same with font sizes. We put fixed font sizes in the HTML, and we used things like -1 if we wanted fonts to be slightly smaller than the default for the browser in question. So all this is put together in the HTML. And the problem from an accessibility point of view is that you had no choices. Everything looked the way the web designer wanted it to look. You couldn't override most of these styles, change them so the text was clearer to read or bigger to look at. There was no accessibility information available to screen readers, the technology that I use. Everything was hard-coded, and if it didn't work for you and it made it difficult for you to look at stuff, well, that was kind of tough. So along came CSS1, a little bit later in 1996 as it happens, and it gave us the ability to use external style sheets so we could do things much more conveniently and change designs across an entire website or series of pages. It gave us the ability to define things like text color, background color, and it also introduced some pseudo-link selectors, so we could start taking away some of those attributes we saw in the HTML and putting them into the CSS. And this was the start of separating HTML used to define content and have good accessibility information, and the design into CSS. It was completely separate, and that was pretty nice and clean. And so we thought, great, let's go and have a cup of tea, because that seems like a pretty good way for us to do things on the web. The trouble is that while we were off having our cup of tea, the accessibility space was changing. Windows 95 introduced the first of the platform accessibility APIs. And over the next few years, all the other platforms that were around or came along introduced their own APIs. So on Windows, there is MSAA, or UI Automation, or iAccessible 2. On OS X, there's the NS Accessibility Protocol, which has now been replaced by the OS X Accessibility Protocol. And there are others for Linux and Android and iOS. And what these APIs do is let an assistive technology like a screen reader query objects on the screen. So before, my screen reader would have to guess at what things were on the screen. It might see an object that was rectangular with rounded corners, and it was on a horizontal line with a lot of other things that looked like the same size and shape. And they all had some text in the middle of them. And so my screen reader would say, well, I think that's a button, and it's in a row with a whole load of other buttons, so maybe this is a toolbar. And that's a really inefficient way of doing things. But what the APIs let screen readers and assistive technologies do is query objects and say, hey, what are you? What do you do? What state are you in? And how do I refer to you? What do I call you? So if we take an example, if we have a look at this checkbox, which is somewhere in the Windows 10 operating system, and we look at it through one of the accessibility APIs, what we discover is that it has a role of checkbox, because that's what it is and that's what it does. It has a label of bold, that's the visible label, but it's also the text label, the accessible name, that's been associated with that checkbox in the code of the software. And lastly, we can find out that this is a focusable element. You can tab onto it with a keyboard, and it currently is checkable and is in the checked state. So that information is just available to a screen reader, and they can use it then to convey useful information to people like me who are trying to use the software. The interesting thing is that if we create the same thing on the web using an input type of checkbox with the checked attribute and a label that's associated using the for and ID attributes, we get exactly the same information. We can discover that it's got a role of checkbox, a label or an accessible name of bold, and it's in the same state as the one we looked at in the software. And that information is designed to stay the same, no matter whether you're looking at something in an application interface, the operating system, or on the web. The way the browser does this is by taking that code, creating the document object model, the DOM tree, something I'm sure you're all reasonably familiar with as designers and developers. But what it also does is take information from the DOM tree and create an accessibility tree. And this accessibility tree is just for assistive technologies like screen readers to use. And they use the platform accessibility APIs to discover information that the browser makes available in the accessibility tree. So the process works a bit like this. You load a page into the browser creates the DOM, it uses information from the DOM to create the accessibility tree. When the DOM gets updated, perhaps because you've scripted something to change or because the user has interacted with the page in some way, parts of the DOM get rebuilt. That means parts of the accessibility tree get rebuilt. And my screen reader is listening for those change events, and when it understands that something has changed, it will ask the platform accessibility APIs to look at the accessibility tree and find out what information I need to know as a user. So there's a whole chain reaction of events that take place in terms of accessibility. So if we take a really simple example, just a standard anchor link leading off to a website, there's a lot of information that a screen reader, for example, can pick up from the page.
Tab, tequila, link.
So that's just hitting the tab key. The screen reader echoes the key that has been pressed, so I have confirmation that I hit the tab key. It finds the link, and it announces tequila, because in this case, tequila is the label, the accessible name for the link. That's how my screen reader knows what to call this link. And then it told me it was a link. So I now know that I can use the enter key to activate it, and I will probably go somewhere and learn something about tequila. And you get all that information for free when you use HTML, because the browser does all that work for you. Another quick example is using heading elements to give sections of content on your page some structure.
Tink heading level 1. Proposed ARIA password role heading level 2 link. Using the ARIA application role heading level 2 link.
So there again, just for using the H1 and H2 elements, you get a lot of information for free. We heard it was a heading level 1, so I know it's the most important heading on the page. The second and third were heading level 2, so I know they are not quite as important as the first. I heard the article titles being read aloud because this is an excerpt from my blog homepage. And I know that those blog titles were also links. And again, all that information just from HTML itself. So, back to CSS. In 1998, CSS2 arrived on the scene, and it introduced lots of new features. But the most interesting one from an accessibility point of view was the before and after pseudo selectors. So it gave us the ability to add content into a page that wasn't in the HTML. So if we just take this basic kind of CSS styling here, we're just going to use the after property to add some text to whatever we want to apply it to. Really simple CSS. And then what we discover is that if we put a link together and we look at the rendered code, we don't see that after content at all. It doesn't show up in the DOM. It's just this plain HTML link, pretty much like the one we looked at before. So here's what the CSS 2.1 specification says about generated content. It says it shouldn't be added to the DOM. So if you remember what we were looking at before, it's information from the DOM that is used to create the accessibility tree. So if this information, this after content, isn't included in the DOM, it seems likely that the browser won't include it in the accessibility tree, and people like me won't ever know that content added with before or after is included in the page. So, who's willing to take bets on whether this screen reader demo now will give us the full tequila makes me happy or just the bit in the rendered content? I'll let you think about that, but you might be surprised.
Tab, tequila makes me happy, link.
So it turns out that although this after content that makes me happy isn't in the DOM, and it isn't in the accessibility tree, screen readers are actually aware of that content, which is something of a surprise, to be honest. It actually turns out that all of the major browsers at the moment will do this: Edge, Chrome, Safari, and Firefox. And they do it by cheating, basically. They ignore the DOM, they ignore the accessibility tree because this content isn't there. What they do is that they add this content to something called the accessible name computation. I do not suggest you go and read the accessible name computation specification. It's horrible. It's really difficult to read, and frankly, better people than me have tried and failed to understand it. But you remember when we looked at the checkbox, I said it had an accessible name of bold? Well, many elements have accessible names, and in this case, the one in the HTML is tequila. But what the browsers do is they're a bit sneaky. They take the content put together through the after selector, and they just add it to the accessible label. And they do this outside of the accessibility tree. They just kind of stick it in sideways and hope for the best. Good news is it works pretty well. There are all screen reader combinations on popular browsers will do this quite happily. So using these before and after selectors from the point of view of screen reader users is really not so much of a problem. So we can all go and have a cup of tea, right? Sounds good. But CSS3 has introduced something else that's quite interesting from an accessibility point of view. There's the FlexBox layout module that's currently a W3C candidate recommendation, which means that before long it'll become an official recommended standard by the W3C. And what it does is let you reorder the content of things on page, or the order of things on page. So if we take a really simple example, just 3 buttons, 1, 2, and 3. With the code like this, then when they appear on screen, things will happen in pretty much the order you would expect. If you're a keyboard user and you use your tab key to move through this content, this is the order you'll hit those buttons in. So as you'd expect, it's the way it looks on screen. You hit 1, then 2, and then 3. And it's all pretty good and pretty simple. until we introduce some of the FlexBox properties. So we use the display FlexBox that sets things up on a container to be a FlexBox container. And then within that, we use the order property, and we can redefine the visual order of the content within the FlexBox container. So in this case, we've said, let's reorder things. Let's put them back to front visually. We'll have them 3, 2, 1 instead. So again, that seems reasonably simple. We've reversed the order. So on screen now, you see button 3, button 2, button 1. If you're using a keyboard, though, this is what happens. You hit them in the order that they appear in the code. So you still get button 1, then button 2, button 3. But if you're a sighted keyboard user, that's completely back to front. It's not the visual order that you're expecting. And so things start to get very complicated. Now, this is a really simple example, but imagine if we were building a web application, something like Gmail or a content management system with a lot of moving parts and a lot of complex bits and pieces. If we start using FlexBox to change the visual order, but it does nothing to change the keyboard order, poor sighted keyboard users are going to get very, very confused indeed very quickly. So this is what the CSS spec says. If you're going to use FlexBox, don't do it to reorder anything that's kind of important, which is crazy, quite frankly, because you guys will know you've been using CSS a long time. How many people really hate floating hacks? Right. So here, we've got a solution that gets rid of those. We don't have to do that anymore. And yet, we come up against the usability and accessibility problem like this, and the spec just says, hey, if it's important, don't use this funky new feature. It's okay. That's never going to work. You know, we live in the real world. We have to design stuff, and this solves so many problems that then to be told you can't use it in most of the circumstances you're probably going to want to just seems a little bit stupid to me. So what can we do to fix some of this? Well, one possibility is the tabindex attribute. We could add a tabindex that basically matches the visual order of the buttons per the order attribute, or the order property. So what we'd be doing is forcing the keyboard order to match the visual order. So if we have a look at a demo, this is what would happen. So you're probably sitting there thinking, hey, that does it, that works. Except the problem is that there are different values you can give the tabindex attribute. If you give it a value of 0, the thing you're making focusable will just appear in the natural sequence of the page. So tabindex 0 on our buttons would not change their natural tab order. If you use -1, you can take something out of the keyboard tab order altogether, which is useful sometimes in complex widgets. But if you give it a positive number, like 1, 2, or 3, then you're taking complete control of the tab order for the whole of the page. So where this works for our little example of 1, 2, 3 buttons, if we put this in the middle of a page of content, it doesn't matter how many other focusable things there were on the page. The first thing a keyboard user would move to when they hit the tab key at the top of the page would be button with the tab index of 1 in this. So although we can solve the FlexBox problem in a very tiny and limited sense like this, as soon as we actually put it into production code and use it out in the wild, unfortunately, it doesn't work at all. So tab index, sadly, is no use to any of us. Another idea that has come about is an aria attribute. Aria stands for Accessible Rich Internet Applications, and it's a bunch of attributes you can add to HTML and SVG to change the information that exists in the accessibility tree. And there's an attribute called aria-flowto, and you can use that to set up a different navigation order for screen readers. Aria at the moment is really only used by screen readers, so it's a very, very specific technology in terms of the accessibility it provides. And again, what we do is we use the aria-flowto attribute to point to the right buttons in the right sequence to match the visual sequence based on the FlexBox order. And again, this sounds, quite promising. Sorry, just see the code there. We're just adding it in, to match the order and the attributes with the flow-to attribute. And then what we should see is a screen reader behaving something like this.
3 button has flows 2. 2 button has flows 2. 1 button has flows 2.
So although things appear to run in the right order, we've got another problem. And that problem is that it adds another layer of navigation. So this is specifically ARIA-based and specifically targeted at screen readers. So it hasn't solved the keyboard problem for anyone who doesn't use a screen reader. It's added another type of navigation that you've got to think about as a developer. So actually, you're making things harder for yourselves. And actually, aria-flowto is only really supported on a couple of screen readers and one, maybe two browsers. So it's not widely supported, even amongst the target audience. So, unfortunately, that doesn't work either. There is an interesting side note to this, though, and that is there is a bug in Firefox where it actually changes the keyboard sequence to match the visual sequence. So when you use the FlexBox and order properties, Firefox just solves the problem for you. You don't have to do anything at all. And if I can see that, the tab order now, just courtesy of Firefox, matches the order on screen, button 1, button 2, button 3. Mozilla calls this a bug because of that line or two in the spec I mentioned earlier, where it basically says, yeah, we acknowledge that this is a problem, and so if it is a problem in your code, then don't use FlexBox. Firefox, to my mind, has done the far more sensible thing of solving the problem for all of us, so you don't have to think about it as developers, I don't have to think about it as a user, and that seems pretty good to me, and a good reason to go and have a nice cup of tea. So while we're drinking our last cup of tea, what I want to do is just look at some of the, one of the more interesting possibilities there are in CSS. There's something called the CSS Speech module. It reached candidate recommendation at the W3C about 4 years ago. Sadly, it seems destined to stay there because only Chrome implements this particular speech model. So I'm afraid what follows from here is not stuff you can go away and implement in your production code, but it is some stuff you can go and have some fun when you're bored on a Sunday afternoon. So what does it do? It gives you a whole bunch of properties that let you control the speech of a screen reader. So you've probably heard from the demos today that screen readers talk in pretty flat, boring voices. You know, they don't get angry, they don't get cross, they don't get sad, they don't sound happy, they just read stuff very slowly, very boring, da da da. So what CSS Speech will do, or could do, is let you as developers and designers change the audio experience for people like me. And there's a whole bunch of different properties. There's the speak property, and that just says, speak this content. It's kind of, on, off. And it's very closely related to display none. So if you set the speech property to auto, it will automatically follow whatever your display setting is turned to. So display none is the equivalent of don't speak, and any other form of the display property will enable speech on that particular element. There are properties for voice volume, which, as you probably guess, lets you determine the volume level of the text-to-speech engine of the screen reader. And all of these settings are relative. So it will take whatever my screen reader volume happens to be and make it louder than where it is or quieter. So it's always relative to the person's individual settings on their computer. There are other setters for speech rate. One thing, as you get to know people who use screen readers more, you'll discover is that we're not patient people. We don't listen to every word, and we don't listen slowly. Like you guys don't read every word of a menu or even an email. We will listen at speed in the same way you skim read or glance at things. And so ability to change speech rate is quite an important part of the audio experience. You can change pitch, so the height or the depth of the voice, and just give it more characteristics like that. And there are a whole bunch of use cases why this might be interesting. If you have a news website, for example, or application, you could read, key headlines, the latest breaking news in a slightly louder voice, for example. You could come up with something that just put notifications in a different voice, so it was something that could be called attention to kind of in an audio sense. There are lots of different use cases. I've also heard a lot of people say, what a really, really horrible idea. I don't want somebody telling my screen reader how to sound. And I kind of figure, well, in an accessibility sense, we keep telling everybody we want equality. You guys have to look at really, really bad designs, so maybe it's only fair that we listen to some really, really bad audio designs too. I don't know. But let's just take a quick look at a very silly prototype demo that just it's a spoof, really. It doesn't actually use the CSS properties because, as I said, the support is really non-existent. So this actually uses the web speech API to pretend to take the CSS values and tell the screen reader how to behave. But this is how it would work in practice if it were better supported.
This sounds normal. This sounds loud. This sounds quiet. This sounds fast.
This sounds slow.
This sounds high.
This sounds low.
So that really just a final note to just show you what's possible in terms of CSS accessibility, some of the challenges, some of the problems, some of the good stuff that's happening without us really knowing it. And I hope you've enjoyed it. Thank you very much.